Okay, let's continue on our understanding of aerospace engineering, aircraft propulsion systems. So previously we broadly defined the topics to be covered, and one of the topics we discussed was Newton's third law of motion, whereas the equation is thrust equals to mass times acceleration. So we can say that the thrust force, is proportional to the mass of the air that the engine is displacing, and also proportional to the velocity difference in the air that is being discharged out of the exhaust compared to the inlet velocity of the air. In the case of a piston engine, a relatively large amount of air is pushed backward, but at a slower speed, whereas a relatively small amount of air is being discharged at a relatively high delta V for a gas turbine engine. Another difference, so that's one difference between the two engines, why the gas turbine engine outperforms the piston engine. Another reason for the lower power to weight ratio for the piston engine is the fact that the piston engine has constant volume in combustion, whereas the gas turbine engine, at least theoretically, has a constant pressure in compression. Because piston engine has constant volume and a high variance in pressure, almost 12,000 pounds per square inch, you are required to have strong and heavy construction of the engine combustion chamber. Also, due to detonation of the fuel, you are required to carry high octane fuels. And this is the consideration for piston engine. When you're designing and building gas turbine engine, because combustion happens at a constant pressure, we essentially are not required to use high octane fuels. We can use low octane fuels, and so relatively light construction materials can be used. So that's another difference between the gas turbine engine and the piston engine. Another way of looking at the two engines is the fact that the gas turbine engine, it's a continuous process, whereas the air is coming in and being compressed and burned continuously, whereas the piston engine operates intermittently. It's injecting fuel intermittently into the combustion chamber, and the other three cycles are idle in the piston engine, whereas the continuous burning of the fuel in the gas turbine engine generates more power, essentially. So that's another difference of the two engines. Now, the other topic we can discuss is thermal efficiency. Because the gas turbine engine burns fuel and air mixture at the exhaust in the expansion stage, exhaust and expansion and exhaust, we are dealing with higher temperatures and therefore greater expansion. And so it's a heat engine essentially, and the thermal efficiency is involved in the gas turbine engine. So then we have to deal further into other topics like the Boyle's law and Charles' law when you're dealing with gas turbine engines. And so we can discuss in our next lecture about the gas characteristics, gas dynamics, which is the relationship between volume, pressure, and temperature, to continue our studies with gas turbine engines. See you next time. Ciao.